Circuit Sudoku 4. If you want to do this one without me jabbering in your ear, stop the video now and do what you want to. All right, here we go. There's our circuit. There are the values we're given. There's no right way to start, but I like to begin by saying, hey, that's going to have a certain voltage. That's going to have the highest possible voltage, those wires. These wires down here are going to have the lowest possible voltage. I'm going to assign that to have 0 volts of electric pressure. How many more pens do I need? How many more different colors do I need to color the rest of this diagram? Only one. All of that is going to have the same voltage. Now, I don't know what that is yet, and we can't fill in the voltage for the red region because the battery voltage isn't given. If the battery voltage was given, you just put that right in there, given this bottom part is going to be 0. But let's see what we've got. We are told that the pressure difference across resistor 3, all right, look at resistor 3 there. The pressure difference across resistor 3, it's 24 volts difference from one side to the other. Well, it's 0 volts on this side. And if the difference is 24, then this blue portion of the circuit is pressurized to a value of 24 volts. And that means that the pressure difference across resistor 4 must also be 24 volts. You see that? 0 on this side, 24 volts on that side, so the difference is 24. All right, you know what? Across resistor 1, we're told the voltage drops by 12 going across resistor 1, which means if it's 24 on this side, it has dropped by 12, which means this is going to be 36. The voltage is always going to get smaller as we go around a circuit like this. That tells us that, first of all, this is a 36-volt battery. It also tells us, look at the colors in the diagram, that the pressure difference, or the voltage drop across R2, is also going to be 12, just like it is for R1. All right, we're cruising now, aren't we? So that's Ohm's law, right? V equals IR, power equals I times V. So that's going to be 6 amps. That's going to be 3 amps. 24 equals watt times 4. That's going to be 6 amps. And 24 equals watt times 8. That's going to be 3 amps. So let's fill in the powers while we can. 12 times 6, 72 watts. 12 times 3, 36 watts. 24 times 6, 144 watts. And 24 times 3 is 72 watts. Now, what about the battery? Let's look at our diagram. How about resistors 3 and 4? Through resistor 3, we have 6 amps. 6 amps flowing that way. All right, I'll go ahead and draw that in there. 6 amps flowing that way. Through resistor 4, we got 3. You see those amps? They flow together right there. That's called Kirchhoff's junction rule, Kirchhoff's node rule. However much flows into that point right there, got to be equal to what's flowing out. That means we must have 9 amps flowing through the battery. 9 amps. Which means this battery thinks there's only one resistor in this circuit. It doesn't know. It can't see. It thinks there's a 4 ohm resistor, and that's it. So 36 times 9, that would be 360, 324. All right, how much do these guys add up to? Just checking. So that's 288 plus 12. Boom. Those do add up. You check it out. Those add up. Let's do one more in this video. Again, stop the video now if you want to do this on your own, because I'm just going to blow through it. All right, here we go. I'm not even looking at the chart. I just like to do this. And you don't actually have to get markers out and do this every time. But mentally, sometimes this is a real helpful thing. The only 0 volt portion of the circuit is going to be that one right there. How many other colors do I need? I need a color right there. That's going to be some voltage. A color over here, some voltage, and I need one more color here if I'm doing different colors. That is going to have a certain voltage. We can fill those in when we need to. All right, this is a 30 volt battery. That means that what I've colored red here, that is pressurized to 30 volts. We're told here that the voltage drops by 6 across resistor 1. So if it drops by 6, then that must mean that this is 24 volts of electric pressure, and that means that the voltage drop across R2 must also be 6. R1 is going to be a 2 ohm resistor. R2 is going to be a 3 ohm resistor. Now, look at this. Through R1, we have 3 amps flowing. Through R2, we have 2 amps flowing. 3 are flowing here and 2 are flowing there. Don't they flow together? And through R3, that would be 5 amps. And you know what? Before R1 and R2, mustn't there have been 5 amps that were flowing through the battery, because they split and 3 go this way and 2 go that way. So through the battery, it must be 5 amps. And you know what? Let's take it back even one more. Mustn't there be 5 amps going through R6 as well? You know what? While we're on that, 5 amps going through R6, 5 amps going through the battery. They split. 3 amps go through R1, 2 amps go through R2, but then they come back together. 5 amps, 5 amps, 5 amps, 5, 5, 5, 5, 5. Oh, right here they split. And according to the table, 1 amp goes through R4. That means 4 amps got to go through R5. All right, I'm going really fast through this, so sorry about that. But I want to make sure that we get through this if we can. So this is going to be 15 volts, and the resistance that's felt by the battery is 6 ohms of resistance. So let's start filling in power. You see why I call these sudokus, because you fill them in whatever order you want. 6 times 3 is going to be 18 watts, 12 watts, 75 watts. This one here will be 32 watts. This one will be a 2 ohm resistor. All right, good. Across resistor 5, we're told that we have 8 volts of pressure difference. Well, that's going to be the same across resistor 4, so that's going to be 8 volts, which means resistor 4 must be an 8 ohm resistor, and the power consumed must be 8 watts. And what about across R6? All right, what's this pink voltage here? Across R3, the voltage dropped by 15. Well, it was 24. If it's dropped by 15, then that means that that's 9. And across resistors 4 and 5, it drops by 8, which means this voltage here is 1. It was 9, it's dropped by 8, so now it's 1. So that means that the voltage drop across resistor 6 is 1 volt, and therefore the resistance of R6, it's not a very big resistance, 0.2 ohms, 5 watts. Those are all our resistors. How much does that add up to? 30, 105, 110, plus 40, boom, 150. Whoo, that's a thing of beauty right there.